Hi guys, in this video we're going to be going over mathematical induction, and we're going to be solving 2 to 3 questions in this video, so stay tuned. The first question we're going to solve is the question on the board, which says 1 plus 2 plus 3 plus 4 down to n term is equal to n into n plus 1 over 2. So we are asked to solve this question using mathematical induction. And in mathematical induction, we have 3 steps in solving mathematical induction. So it's more like we making an assumption while solving issue or problem under mathematical induction. So at the first step, we have 3 steps in solving mathematical induction. The first step says that, well, we should prove that n is equal to what? 1. So we should prove that n is equal to 1. Remember, n in the left hand side is the first term. So, and here for the right hand side, we're going to substitute n equal to 1 for the right hand side. So when we come to n equals to 2, we're talking about the second term, which is the first term plus the second term. So we're talking about n equals to 3, we're talking about the third term, which is n plus 2 plus 3 as the third term. So let's take the first step. For the left hand side, n is equal to 1, which is the first term. For the right hand side, we're going to substitute the value of n, which is 1, in the right hand side. So we have n into n plus 1. So we have 1 into 1 plus 1 all over 2. So we have equal to 1 into 2 all over 2, which is the same thing as saying 2 over 2, which is equal to 1. So we've shown that we've proven that n equal to 1 is equal to 1. So we're going for n equal to 2. So for the left hand side, n equals to 2 is what? Is the second term. So on the second term, we're going to multiply the first term and the second term. So for the left hand side, n, which is the first term plus second term, we have n equal to 3. For the right hand side, we're going to substitute n equals to 2. So we have n, which is 2, into 2 plus 1 all over 2, which is equal to 2 into 3 all over 2. You can either multiply 2 by 3 to have 6 all over 2, which is the same thing as 6 divided by 2. 6 divided by 2 is 3. So for n equal to 2, it's correct for n equals to 2 because for the left hand side we have 3, and for the right hand side we also have 3. We can further keep solving for n. So now let's move to the second step, step 2. Step 2 says that we should assume that n is equal to what? K. So we're just assuming that what? N is equal to k. So now in our equation, anywhere we see n, we're just substituting, we're interchanging the value of n to be equal to k. So we have 1 plus 2 plus 3 plus 4 down to the n term. So now we're going to replace it by what? K. So which is equal to what? We have n into n plus 1 all over 2. So it's going to be k into k plus 1 all over 2. This is just for this is all for the step 2. We are just assuming. So we are replacing n to be equal to what? K. Now we're going to the step 3. So step 3 step 3 says that we should what? We should prove that n equals to what? K plus 1. N equals to what? K plus 1. So anywhere we see k, anywhere we see k, we are just going to what? Substitute the value of what? K plus 1. So anywhere we see n, we're going to substitute k plus 1, which is they are incrementing n by 1, which is what? The next term. So we have 1 plus 2 plus 3 plus 4 down to what? K plus what? Incrementing by 1, we have what? K plus 1, which is equal to k. So now we see k will put what? K plus 1. Then since we have k plus 1 here, we have what? K plus 1, then plus 1 all over 2. So what we're supposed to do here, or what we are required to do here, is what? Show that this part, the left hand side, is equal to what? The right hand side. That's what we're going to do. But by the time you go back, when we solve it, you realize that this part, which is 1 plus 2 plus 3 plus 4 down to k, is equal to this is equal to k into k plus 1 all over 2. Then only this part here is equal to this plus k plus 1, that is equal to k plus 1 into what? K 1 plus 1, what? 2 all over what? All over 2. So here we can look for the LCM, or first of all we can just what? Multiply this k by everything here. Then at the end of the day we still look for our LCM. So we have k square plus k all over 2 plus what? K plus 1 all over 1, which is something as saying k, we can factor we can expand this bracket by saying k multiplied by k multiplied by 2, 1 multiplied by k, 1 multiplied by 2. So k multiplied by k, we have k squared. K multiplied by 2, we have plus 2k. Then 1 multiplied by k, we have plus k. Then 1 multiplied by 2, we have plus 2 all over 2. Then we can look for LCM here. Our LCM here is what? 2. 2 divided by 2, 1. Then 1 multiplied by everything here, we have k square. Sorry, 1 multiplied by k, we have k square plus what? K. Then plus 1 divided by 2, we have 2. Then 2 multiplied by k, we have 2k. Then 2 multiplied by 1, we have what? 2 is for the left hand side, which is equal to k square plus 2k plus k plus 2 all over 2. So the next thing to do, we can remove this fraction by either cross multiplying, or by what? By multiplying both sides by 2. We can just multiply both sides by 2, multiply both sides by 2. So this 2 will cancel this, then this 2 will cancel this, then we're left with what? Just k square plus k plus, sorry, instead of writing k plus 2k, we have 3k plus 2. Is that correct? K square, k plus 2k, we have 3k plus 2. Yes, that's correct. Equal to, then we have k square, then 2k plus k, we have plus 3k, then plus 2. we can see we've proven using mathematical induction that the left hand side, or for n equal to k plus 1, is correct. So the left hand side is equal to what? The right hand side, using mathematical induction. So let's see how we can solve one or more examples for you guys to understand. So we're going to solve example 2. Example 2 says that we should prove using mathematical induction that a plus ar plus ar square plus dot 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 and a r to the power of n minus 1, which is equal to a into r to the power of n minus 1 all over r minus 1. So this is the example 2. So we're going to prove these using mathematical induction. The first step, as we've said in example 1, is to prove that n is equal to what? 1. And remember, n equals to 1 on the left hand side, they're talking about what? The first term. So the first term here now is what? Is a. So when we're talking about n equals to 2, we're talking about the second term, which is first plus what? The second term. So for the right hand side, we're just going to substitute n equals to 1 on the right hand side. That's anywhere we see n, we substitute the value of what? N. Then we what? Show if the left hand side is what? Equal to the right hand side. So for the left hand side, n equals to 1 is talking about what? The first term. So a. So let's see if we're going to have a on the right hand side when we substitute the value of what? N, right hand side. So we have a into r with the power of n. So anyway, we say n what? 1 minus 1 close bracket all over r minus 1. So n raised to the power of 1 is still that number, still that thing. So r minus 1 will cancel r minus 1, then we're left with what? A. So left hand side is equal to what? The right hand side. So n equals to 1 is correct. So let's see n equals to 2. N equal to 2. N equals to 2. For the left hand side, n equals to 2. We're talking about what? The second term. So to get the second term now, we are multiplying what? The first and what? The second term. So we have a, which is the first term, plus ar, second term. So look closely, we have a plus ar. So what's common? Obviously a is common. So we factor out what? A. We factor out a, we now have what? A, factor out a here, we have 1. Because if you say a multiplied by 1, we have a plus r. Then a multiplied by r, we have ar. So this is what we have on the what? Left hand side. Let's see when we substitute the value of 2 on the right hand side, whether we're going to have a into 1 plus r to show that n equal to 2 is correct. So for the right hand side, we have a into r with the power of n. So our n is what? 2. Then minus 1 all over r minus 1. Remember, when you have this can be raised to the power of 2 too, because when you say 1 raised to the power of 2 is what? It's 1. So this is obviously difference of 2 square. If you don't know, you check out my video on difference of 2 square. So a into r difference square, you're going to have what? The two numbers. The first is going to what? R plus 1, r minus 1. This is how difference of 2 square is. This is how difference of 2 square works. Then all over what? R minus 1. So that r minus 1 will cancel r minus 1, and we're left with what? A into r plus 1, which is the same thing as saying a into 1 plus r. They are commutative. So whichever way you flip it, it's still the same thing since it's uh, addition. So we've proven that n equals 2 is correct for the left hand side and as well as what? The right hand side. So the next thing now, we quickly move towards step 2, where we're asked to assume that n is equal to what? K. So in that, it's just substituting n equals to what? K. That's for the step 2. That's the only thing. They say we should just assume that n is equal to what? K. So obviously that's what we're going to do. So a plus ar plus ar square plus dot 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 plus a raised to the power of n term minus 1 is equal to, okay, sorry, instead of putting n here, we just simply put our k, because here they say we should assume that what? N is equal to k. That's step 2. Then it's equal to what? A into what? R is to the power of what? K, since we're assuming that n should be equal to k, all over r equal to 1. This is what we are asked to do. It's just an assumption. So we are just quickly going to dive into step 3. So we don't want the video to be lengthy, and I hope you guys are understanding. So the step 2 says that we should solve, or we should prove that what? K, like n is equal to what? K plus 1. They're incrementing what? K by what? By 1. So they say we should what? Prove that n is equal to what? K plus 1. So step 3. Step 3. N is equal to what? K plus 1. We should prove. So now, anywhere we see k, we're just substituting what? K plus 1. But for the left hand side, they are incrementing k by 1. So this is the next, after this, we're going to have what? K plus what? 1 as what? As a next term. So we have a plus ar plus ar square plus dot 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 plus a. Yeah, we're having minus 1 here. What? That's minus 1 here. Then it's equal to, this is our next term. So it's equals to a into r raised to the power of k plus 1 minus 1 all over r minus 1. So look closely. From here, it's equals to what? This. Look. So we're going to we're going to replace the whole of this with this, since the whole of this from here is equal to this. So quickly going to replace that. A into r k minus 1 all over r minus 1, then plus, here we have ar, here we have plus 1 minus 1, that's 0. So we're left with just k, which is equal to a into r k plus 1 minus 1 all over r minus 1. Let me quickly clean up. So now we're just going to prove that the left hand side is equal to the right hand side for n equals to k plus 1. We have a into rk minus 1 all over r minus 1 plus series of k all over 1, which is equal to everything on the right hand side, a into r is power of k plus 1 minus 1 all over r minus 1. Okay. So now we're just going to look for what our LCM here, since this is fraction, we're having addition sign in between them. So our LCM now is r minus 1. R minus 1. R minus 1 divided by r minus 1. We have 1. So we 1 multiplied by everything here. We have a into r is power of k minus 1 minus 1 plus r minus 1 divided by 1. We have r minus 1. So r minus 1 multiplied by whole of this, we have r minus 1 a r k equal to the right hand side, which is a into r k plus 1 minus 1 all over r minus 1. So here we can multiply this a all through, then multiply, then open this bracket using ark, then multiply, expand this bracket using a. So we have a rk minus a plus here we have r here, we have r here, so we have 1 here. So since the base are the same, we're multiplying a ark multiplied by r. Since they are the same in your indices, since the base are the same, here we're having invisible one. Since they are the same, what we add the powers. So we have r is power of k plus 1, then minus a r k all over r minus 1 on the left hand side equal to a into r is the power of k plus 1 minus 1 all over r minus 1. So let's look closely. Let's slash out. We have a ark minus a ark. So this word cancel this. Then we are left with minus a plus a r raised to the power of k plus 1 all over r minus 1 is equal to a into r raised to the power of k plus 1 minus 1 all over r minus 1. So what can we do to see that our left hand side is equal to our right hand side? Let's look closely. We're having a outside, so we're just going to do one step and we're going to arrive at our answer. So here we have a, which is common between this side and this side, so a is common. So we're going to factor out a so that we have our left hand side to be equal to our right hand side. So we're going to factor out a. When we factor out a here, we have minus 1, because when we say a multiplied by minus 1, we have minus a, then we have plus r raised to the power of k plus 1 close brackets r minus 1, which is equal to a into r raised to the power of k plus 1 minus 1 all over r minus 1. Sorry, let me quickly click here. So we've gotten our answer, but let's interchange a into, we're going to write this first, which is r k plus 1 minus 1. It's still the same thing, we just interchange it, and this minus is attached to the one, so we're moving to the other side. This one is positive, we're putting it to the front, all over r minus 1 is equal to a into r raised to the power of k plus 1 minus 1 all over r minus 1. You can see that our left hand side is equal to our right hand side. we've proven that n equal to k plus 1 is correct for solving mathematical induction, which is this step 3. uh let's see how we can solve the last example for sake of practice. Okay, we're going to be solving example 3, which is the last example for this video. We have to prove example 3. We asked to prove a plus into a plus d close bracket plus into a plus 2d close bracket plus dot 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 dot. Then we have a plus n into n minus 1 d. It's equal to what our right hand side, n all over 2 into 2a plus into n minus 1 then d. So we are asked to solve. This is the example 3 and the last example. So we are asked to solve using mathematical induction. So what we're going to do is, I'm going to be a bit fast since it's the last example. To prove that n is equal to what? 1. And we know that for our left hand side, n equals to 1 is always what? Our first term, and n equals to 2 is our second term, and n equals to 3 is our third term. Then for the left hand side, we're going to substitute the value of n, which is 1, into anywhere we see n. So left hand side, we have a. For the right hand side, we're just going to substitute the value of n, which is n, we have 1 over 2 into 2a, then plus into 1 minus 1 d. So 1 minus 1 is 0, and 0 multiplied by d to go 0. So we're left with just 1 over 2 multiplied by 2a. So we have 2a, because you see here it's just saying 2a multiplied by 1, we have 2a all over 2, then these 2 cancel 2, we have a what? A. So 2 divided by 2 is 1, so 1 multiplied by a is still a. So n equals to 1 is correct. Let's see n equals to 2. N equals to 2. N equals to 2. Remember, for the left hand side, we're just going to deal with what? The first and the second term. We're multiplying the first and second term, which is a plus into a plus what? D. So you see, a multiplied by a plus d, so we have 2ad. So we have 2a d here, 2a d. So this is our n for the left hand side. This is what we get. Let's see if you're going to have, you are still going to have 2ad, 2a plus d on the right hand side when we substitute the value of n, which is n equals to 2. So n, we're going to have 2 all over 2, then 2a, then plus into n, we have 2, then minus what? 1, then our d, then d. So 2 divided by 2, obviously we have 1, then 2 minus 1, we have 1, then 1 multiplied by d, we have what? D. So we're left with what? 2a plus d. It's simple. 2 divided by 2, 1, then anything multiplied by 1, by the time we multiply all of these by 1, we still have what? All of these. Then 2 minus 1, we have 1, and 1 multiplied by what? This d, we have what? Just this d. Then we're left with what? 2a plus what? D. So you can see 2 for n was 2. We got this, which is what? Correct. So we quickly move toward the step 2, where we asked to just assume that what? N is equals to what? K. So we're just going to be substituting the value of what? Of n, which is equal to k, anywhere we see n. So we have step 2. Henceforth, I'm not writing the steps again. So a plus into a plus what? D plus into a plus what? 2d plus dot plus a plus, and then we see n equal what, k minus 1, then d equals what, right hand side k over 2 a plus into what, k minus 1 plus bracket d. So this is for what, step 2, because we only asked to what, assume, and with what we've made assumption by what, changing n to what, to k. So we're going to see the step 3 that says what, we should solve or prove that n is equal to what, k plus what, 1. So obviously that incrementing k by what, 1, which is on the left hand side, is what, our next step. So here we're just going to what, increment this by what, 1. So you see we're having 1 here, so we're incrementing here by 1. So a plus d, that's step 3, and equals to what, k plus 1. So here now we have plus a into, okay, sorry, plus a plus 2d dot plus a plus k minus 1. You're not touching this term, that's why we should increment by 1. So we have plus and open bracket k plus, so here we have k plus what, plus 1. So k plus 1, we have k plus 1. This is what they say we should increment. So we still have minus here, so we're going to put our minus plus bracket d, so equal to, anywhere for the right hand side, anywhere we see k what, k plus 1 all over 2a plus in brackets k plus 1. So k plus 1 minus 1 is still what, k. So we have what, just put d, which is kd, because you're having k. If we substitute k, we can say let n equals to what, k plus what, n equals to what, k plus 1. So we're using this here, not even this, we're using this here. So anyway we see n, we have to what, put n which is equal to what, k plus 1. So putting k plus 1 here, we're going to have k plus 1 minus 1, which is what, k. That's why we're having what, kd. So remember, see, from here, all of this is equal to what, this. I hope you understand that all of this is equal to what, this here. Look, no different. All of this is equal to what, all of this. So we're going to change all of this, interchange all of this what, with this, so that we can what, make our work easy. So we have k over 2 into 2a plus k minus 1 d with what here, then we still have what, our last term, which is a plus, so here k plus 1 minus 1, so we have just k, which is k plus d. We have k d. I hope you guys are following. So our right hand side, k plus 1 over 2a plus k d. So here now, look carefully, this is fraction. We can expand this bracket, can multiply k all through, then look for our LCM, or we can do it the same. So okay, let me just expand this first. So we have k into 2a, we have 2ak plus k into k, we have k square, k multiplied by minus 1, we have minus k. Sorry, before we do that, see, this d is also multiplying everything here. So when we say k multiplied by 2a, we have 2ak Then this d multiplied by k is what? Is kd, then multiply minus what? D. So when we multiply this with this, now we're going to have what? K squared d, then minus kd, which is this one has already been replaced by this k and by this d. So we have kd all over 2. I hope you guys are following. So now we have plus this part here, a plus k d all over 1 is equal to k plus 1 over 2 into 2a plus k d. Let me quickly clean off some space so that we can prove that our left hand side is equal to our right hand side. So here now, look, we're having fractions. So we're going to take our LCM so that we can show, but this right hand side we're going to leave it like this. Then there's a way we're going to do play with our left hand side so that so that it will look like the right hand side. So our LCM is 2 and 1 is 2, so 2 divided by 2, 1, so we have 2a k plus k square d minus kd, which is plus, remember, plus our LCM, then 2 divided by 1. You now have to look for LCM now. 2 divided by 1, we have 2. Then 2 multiplied by a, we have 2a. Then 2 multiplied by kd, we have plus 2kd, which is our right hand side equals to what? K plus 1 over 2 into 2a plus kd. So let me rearrange, let me collect like term. So we have 2ak plus 2a, then we have kd squared plus k squared d, sorry. Then here we have minus kd plus 2kd, so it's going to be what? Plus, that's 2 minus 1, we have minus kd plus 2kd, just like saying 2 minus 1. So we have just kd all over 2 is equal to what? K plus 1 over 2 into 2a plus kd. Then look, these two we have, for this part and this part we have like term. What is the common term here? 2a. Yeah, the like term is the like common term there is 2a. Then for this you have kd here, we have kd here, so I'm going to factor out 1 kd. So we have factor out 2k. Here now we have just k left, then here plus 1. By the time you say 2a multiplied by k, we have 2k, 2ak, 2a multiplied by 1, we have 2a. So we're done with this part. Then plus, we factor out kd, and kd here we will left with k. Kd multiplied by k, we have k squared d, then plus kd, we have 1 here. Kd multiplied by 1, we have kd all over 2, which is equal to k plus 1 over 2 into 2a plus kd. So our aim is to make our left hand side equal to what? Our right hand side. So what are we going to do? We can see clearly that we have k plus 1 and k plus 1, which is what? Common here. So we factor out what? K plus 1. You understand? So by the time we factor out k plus 1, then we're just going to have this into, which is 2a, then what? Plus k d. See here, kd all over 2, which is equal to k plus 1 over 2 into 2a plus what? Kd. You can see that we've shown, or we've proven, that our left hand side is equal to what? Our right hand side from our step 2, that says that what? We should assume, we should prove that n is equal to what? K plus 1, and we've shown that. This side, the only thing we did here is what? Factor out k plus 1. So by the time we factor out k plus 1, we're left with what? 2a here, then plus what? Kd. So by the time we expand this, k plus 1 multiplied by 2, we have 2a k plus 1, which is this. Then k plus 1 into this, we have what? Kd k plus 1. So we've proven. We've come to the end of today's class. Please like, share, comment, and subscribe. See you in the next video. Thank you.